In grade 10, you have done the two kinds of charges, which is the positive charge and negative charge. You have done that the positive charge is carried by protons. I just talked about it here in the nucleus. And negative charge is carried by electrons. So positive protons, positively charged. Electrons, negatively charged. The other thing, we're saying object can be positively charged, negatively charged, or neutral. I talked to that. They can be negative, positive, or neutral. So it's important as we give you a statement, you got to understand whether the object is positively charged, negatively charged, or neutral. You will see we'll be dealing with that aspect now. Neutral objects have equal number of positive and negative charge. Just shown you when we're explaining the pretest there to say the number of protons and the number of electrons on a neutral object, they are equal. However, immediately when you see an atom having a positive charge, you know that it has lost electrons. When you see an atom with a negative charge, you know that it has gained electrons. Now, unlike charges are attracted to each other. We talked about that when we're talking about the issue of electric field patterns. And we said like charges are repelled from each other. You have seen when we have a positive and a positive, they repel one another. When you have a negative and a negative, they repel one another. But when you have a positive and negative, you saw how the electric field patterns are drawn. And we're saying charge is neither created nor destroyed. So you cannot create, just like energy, you cannot create energy nor destroy it, but it can only be transferred. So the same with the charges, you can only be able to transfer. It means if we have a charge from this body, we can transfer it to, from this object, we can transfer it to another object, but you will never create, no. So the charges are there. We're not creating them. We're not creating them. We just transfer them. So it's the only thing that we can do to the charges is to transfer them. So it means when we are saying this object is neutral, we are talking to the issue of the charges being balanced, the positive and the negative. They are there, but they are equal. Hence, we can be able to transfer them and they will become unequal. Hence, when an object is positive, we know that we have lost an electron. When it's negative, we know that we've gained electrons. Now, and we're saying charge is measured in coulomb. Coulomb is capital letter C, not small letter c that you use for concentration in paper 2. Coulombs is capital letter C. Don't make a mistake of writing coulomb in small letter C. And we're saying charge is quantized in units of the charge of an electron. So that is the principle of quantization of a charge. We're saying charge is quantized in units of a charge of an electron. That is, a charge of an electron is minus 1,6 times 10 to the power of minus 90. Conductors, we were saying they allow charge to move through them easily. You know, we talk about good conductors. Good conductors is those that will allow the charges to move. Insulators do not allow charge to move through them easily. And identical conducting spheres. When we're having conducting spheres that are identical, when you bring them in contact, so when we're having, for example, Q1 plus Q2, when you bring them in contact, what happens is that you will say the new charge will be Q1 plus Q2 over 2. I've seen a question where they brought a third charge. You can't say we're not taught about the third charge. If you bring the third charge, you will have Q1 plus Q2 plus Q3 divided by 3. Still, you will get a new charge that we're having. And then all this, the new charge that all Q1, Q2, Q3 will have, they will now have the same sign. They will either be positive, all of them, or negative, all of them. You will see now. So it's important that you have that knowledge. In terms of our exam guideline, it refers to Q1 plus Q2 divided by 2. But if there is a question that involves 3 charges, you know that you will divide those charges by 3. Now, I talked about the principle of quantization of a charge, where we said these charges, they are quantized. We said now they have the charge of an electron is equals to minus 1,6 times 10 to the power of minus 9 coulombs. So you know that is the charge of an electron. But now we have to talk to the principle of conservation of a charge. Principle of conservation of charge. Remember, immediately when a grade 12 learner sees the principle of conservation, already you have done so many principles of conservation by now that I know that you are singing them. The principle of conservation, you've done the principle of conservation of mechanical energy in grade 10. That is still applicable in grade 12. Where we said when you see principle of conservation, you will say the total. The total. This one is saying principle of conservation of a charge. You will say the total charge in an or of an isolated system is conserved. The total charge. So you're just bringing here total charge of an isolated system. Total charge of an isolated system is conserved. So it's important that you know the principle of conservation of a charge. And then we are saying Coulomb's law. We said the magnitude of the electrostatic force exerted by a charge Q1 on another charge Q2 is directly proportional to the magnitude of the product of the charges and inversely proportional to the square of the distance between them. So you are happy there. You must just flow and do as much as you can. Define electric field. Remember, we've defined it already to say electric field is a what? Is a region of space or region in space. So you're having a region in space or region of space where a charge experiences a force placed on that point. So when it's placed on that point, that charge will experience a force. So we're saying when you're outside of the field, you won't experience the force. But what is the electric field? We're saying it's a region of space where a charge experiences force. So the charge will experience a force. And then electric field at a point. We said electric field at a point. Here we're saying it is the force experienced, the experienced force per unit positive charge placed on that point. Don't forget per unit positive charge placed on that point. So you are armed. You are armed with all this information as you go to solve the problems. And remember what we said. We said if we are having now Q1 plus Q2, if we're having two charges that are brought together, identical charges are brought together, we said you must be able to get a new charge by adding them, dividing by 2 like that. So all this information is what we're going to utilize as we go to questions. But before we do questions, it's always important, and we're always emphasizing the use of a data sheet. You got to know this question belongs to which a topic. That is the first point. You must be able now to deal with the question in that we refer to that as you deconstruct the question, and then you check the first thing that you categorize it to say the first thing that when I get a question, I'm going to categorize it. How do you categorize the question? You are saying which topic are we dealing with here? So you're going to do characterization by the topic to say which topic. You said is electrostatics. Then you go to the data sheet for electrostatics so that at least when you are asked questions, you are able to respond. Remember, sometimes you are integrating topics. You heard me, I was talking about Newton's third law under these topics. So there will be those integration with other topics, but the main thing you must know that as I'm dealing with this question 7 in my paper, I will be dealing with this data sheet, which is data sheet for electrostatics. And then Coulomb's law, you are able to remind yourself there. The magnitude of the electrostatic force exerted by one charge Q1 on another charge Q2 is directly proportional to the magnitude of the product of the charges and inversely proportional to the square of the distance between them. So that formula is enough to remind you how to state Coulomb's law. And then as well, electric field at a point. We talked about it, electric field at a point. To say electric field at a point, we said is the force experienced per unit positive charge at that point, placed at that point. So you see that now already you know too. You know electric field, what we said about electric field, we said it's a region in space where a charge experiences force. So you're able to know those 3 definitions, and this data sheet will always help you now. You know when you say calculate the electric field, you have the formula. Remember, we said we are looking here for the contribution of each charge. What is the contribution of this charge? Then you are able to calculate. So we deal with them. When we talk about electric field, we're talking about each charge, the contribution of each charge, which means we only have one Q that we talked about. When we say inert, we're saying add all the contribution of these charges, their electric field. Then you are able to add and get what we call inert. And we said we're dealing with two dimensions and one dimension. One dimension where everything is on a straight line, can be horizontal, can be vertical. But two dimension, we're having a right angle triangle. I think I've emphasized that a lot. I think you know that formula you've done from grade 10 as well. You have been using that formula of potential difference equals to the work done or energy transferred per unit positive charge. I find this very useful, even as you will be doing electricity when you are defining EMF. To say the EMF is the maximum energy. It's the maximum. Remember, work done is energy transferred. So it's just, you're just putting maximum there to say this is the maximum energy per unit positive charge. That is the maximum energy supplied by the battery per unit positive charge. So you're just putting the maximum there. You can define EMF, but this is the definition of potential difference as well. So you know that the datasheet has a lot of information that is very valuable for you. Now, we talked about the quantization of these charges. We said now you know that the charge of an electron is minus 1,6 times 10 to the power of minus 19 coulombs. And then obviously the charge of a proton will be positive because we said the protons are positively charged, which will be positive 1,6 times 10 to the power of minus 19. So you're able to calculate now the number of your particles there, be it number of electrons, where you will say charge over charge of an electron. So you just take the charges that you are given, you divide by the charge of an electron, which is minus 1,6 times 10 to the power of minus 19, and then you're able to get the number of charges. Learners sometimes confuse this N with the number of moles. We're talking about here not the number of moles, but the number of particles, which can be number of electrons, number of protons that you are asked to answer here. So if you have that in mind. Don't confuse it to look like number of moles. Now we go straight into questions now. Activity for all the remaining time. We'll be dealing now with the real stuff, which is questions, because we're expecting that in the exam, you will be dealing with questions. Remember, we always give you 4 options, and we are saying of those 4, 2 of them, we refer to them as distractors, which are obviously incorrect answers. So it's important that you identify those, you remove them, and as you remove them, you are able to know which one now. You are increasing your chances. Remember, when we're dealing with multiple choice questions, we are simply saying that you have 25%, 1 over 4, 25% chances of getting these 2 marks. That's what we are saying when we start this question. But what are we saying? We're saying no. Now remove 2 so that you have 2 over 4. When you have 2 over 4, it means you have increased your chances to 50%. Hence, we're saying distractors must fall. Let's remove the distractors. They are there to distract us from what we want to achieve. Now, let's go to the question itself and apply this principle and this strategy of responding to multiple choice questions. This question is saying 2 oppositely charged point charges move towards each other. They move towards each other. Okay, they are opposite. So you see positive and negative. Okay, which one of the following is correct? So we're looking for the correct answer. They're saying the point charges move at constant velocity. Remember, I think I've shown you with the magnetic field to say as you bring the north and the south pole closer, you can see that as they become closer to each other, they are moving even much faster because the force is increasing. As we decrease, remember the relationship there, as we decrease the distance between them, the force increases. Remember we said the electrostatic force is inversely proportional to the square of the distance between them. So as you bring them together, you're expecting that now the object won't be moving with a constant velocity. Definitely the velocity increases because the force is more, it increases as the distance decreases. So you're able to see that, okay, we're expecting that it cannot be constant velocity, it cannot be constant acceleration. So these are definitely our disruptors. So now what is happening? And the correct answer is that now we are talking here about acceleration, which is now, it means when the object, opposite charge object, when they are moving towards each other, they increase, the acceleration is increasing. They accelerate. A good language is that they accelerate towards each other. And then because the force is highest when you have that. So the option there will be D. I hope that helps you when you deal with such kind of answers. See, let's remove the distractors and be able to get the correct answer. Now, a structured question. We are saying here two small identical spheres. So we're having two small identical spheres, which is the sphere P and sphere T. You can see them there. You see now, you cannot be confused because they are vertical. It's still the same concept. It's one dimension, and then we move. Now are placed at a distance of 0.1 meters apart. So our R is given. The force is, if they will say calculate the force, I think you will enjoy this one because you have everything. You have the Q1, Q2, you have the two charges, and then you have the distance between them. All you need is the constant now, and then you are able to answer the question. Now, state Coulomb's law in ways. I hope by now you are singing it. You'll be able to say the magnitude of the electrostatic force exerted by one charge, Q1, on another charge, Q2, is directly proportional to the magnitude of the product of the charges. Don't forget, it's the product of the charges, and inversely proportional to the square of the distance between them. Remember, you can't write it in a formula, you must write it in weights. So you write the whole of it, and that's, as we've been discussing it, there it is. The magnitude of the electrostatic force exerted by one point charge on another point charge is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. And then you get your 2 marks here. So expect 2 marks or nothing. So it's important that you know it and you state it well so that you get your 2 marks there, and then you are 2 marks richer. Now the next question, draw the resultant electric field pattern. Resultant electric patterns due to the charges on P and T. So you can see that we have a positive and a negative. You can see already that now we will have the two. Remember, we said our arrows, they will always be moving from positive towards negative. So from T to P, that's where our arrows must be moving, from T to P. And then that's how we'll draw our electric field patterns like that. There you have it. You see that you have the T that is negative, then you have the arrows that are pointing towards that. But I want to take you through the marking criteria there for this graph. To say the first mark will be for the shape. The shape. You can see it's a nice drawing. Do that. Love what you are doing because you want 3 marks. Remember, 3 marks in physical science is 1%. 3 out of 100. Already you have 1% in the exam by understanding this electric field pattern. So it's very much important that you do this and you do it correctly. So I'm saying 1 mark is for the correct shape. 1 mark is correct direction from P to T. You can see the direction. There's our arrows. They are towards T and away from P. So that is the second mark. The third mark is that the lines must not cross. Please, we are emphasizing that the lines must not cross and must touch the spheres. So at the end of the day, the line starts from P, it ends at T. It must start the spheres. But you see that they don't go inside the spheres and draw lines inside there where there is T and P there. You know that now you are going to do like that. They must not cross and must touch the sphere. They must touch. You can't draw the lines, then they come somewhere, they stop. Or your lines, as you draw them, they are crossing one another. So take care. This is 3 marks. This is 1% of your final exam mark if you get a question like this one. So please draw it and collect the entire 3 marks, and then we are able to move forward. Now let's go to most structured question. Now. Now we are saying two small identical spheres, P and T. So we're having P and T. We're saying they are placed at a distance of 0.1 meters. You see the first ones that we talked about. And then as shown in the diagram below, P carries a positive charge and then T carries a negative charge. And P carries a positive 3 times 10 to the power minus 6 coulombs. T carries minus 3 times 10 to the power minus 6 coulomb. A third charge sphere S of unknown charge, so we don't know whether the charge is positive or negative, is placed at a distance of 0.1 meters. 0.1 meters from the sphere T, such that the three charged spheres are at vertices of a right angle triangle. So we are having our two dimension there. The net electrostatic force between sphere T due to the other two charged spheres has a magnitude of 10 newtons. So F net that T experiences is 10 newtons as indicated. So that is our resultant there, which is 10 newtons. Now, is the charge QS positive or negative? So you can see definitely that we are going to have a positive one in terms of our charge QS. And then calculate the number of electrons. Calculate the number of electrons added to or removed from the sphere S to give it a charge of QS. So we have to calculate the number of electrons. You see, it's a nice question because most of the time you are used to questions where you say calculate the electrostatic force and the likes. But now this one is saying calculate the number of electrons added to or removed from sphere S to give it to charge QS. So you are able to answer that question. And because we are dealing with that, you can now use, remember we said here, we can deal with the issue of F net. And F net for a right angle triangle, we use theorem of Pythagoras. So F net squared equals to FTP plus FTS. All of them are squared. So it's this the force here between PT and the force between TS as well, here and there. You are able to get another force. So we have the first force, which is FTP, this one, and FTS, this one. So we have to calculate all these forces and then we have to add them. Remember, it is their square that we are dealing with now. So you see that your maths, your calculator must be handy because you're going to have to deal with this type of equation. And then for you to deal with F net already, you were given that it is 10 newtons, which is our resultant force. And then you are having here the formula KQ1 Q2 over R squared for TP and another KQ1 Q2 over R squared for TS. So you're able to do that. And then you write the formulas, the two of them as we did. And then you'll get 1 mark for your formula there. And then substitution. You have to be able to substitute. You're going to substitute F net, which is 10 newtons. You are going now to substitute our K, proportionality constant, which is 9 times 10 to the power of 9. You substitute now, here you have 3 times 10 to the power of minus 6 and minus 3 times 10 to the power of minus 6. So you're able to substitute there easily. And then the distance between P and T is 0.1. So it will be 0.1 squared. So this part, you are well. You got your 1 mark. Nice. You remember is squared because we're using the theorem of Pythagoras. Now you add it. You add it now to for TS, we're having K, which is 9 times 10 to the power of 9. And then Q1, we are having 3 times 10 to the power of minus 6, which is that one. And then that one times Q2, which is unknown. Remember our Q2 is QS here, which is unknown, is what we must first get. And all of them squared. You see, the signs now end here, and you got now your 4 marks for the signs. That is the signs here. What is left is your maths. So important that you practice how to solve these problems. You deal with many problems as possible, And we're always encouraging you to say the calculator that we are using, ensure that you are using the same calculator so that you don't have problems of having to learn a new calculator during exam. Then if everything done correctly, you are able to get QS, which is 4,887 times 10 to the power of minus 6. And then immediately when you get QS, you know the formula that we have given you. Q equals to NE, and then we want the number of electrons. Remember the formula that we said, number of electrons. We said number of electrons equals to charge of an electron divided by, the charge divided by charge of an electron, which we said is negative 1,6 times 10 to the power of minus 19. So that's what you're doing. You substitute the charge, you got it, it's 4,887 times 10 to the power of minus 6. You put your 1,6 times 10 to the power of minus 19 for the charge of an electron, and you are able to calculate the number of electrons, which is N equals to 3,05 times 10 to the power of 13. And then you got your 2 marks there. And then you add them to that 2, which is 6 marks. And then the only gray area that we are saying do as much practice as possible is to be able to move from here, the maths part here, to say please spend some time here dealing with the maths so that you know how to calculate the QS, and then you are able to do that. I know that you have transposed, you took this one, all of it, you subtracted it from the 10 squared, which is 100, minus all of that, and then you are left with that one, that side, and then you are able to cross multiply until you get your Q2, which in this case your QS, which is 4,887 times 10 to the power of minus 6, and then you do like that, then you got your answer, the number of electrons as 3,05 times 10 to the power of 18. So I hope that helps you and you will know how to deal with questions like those. Now, here in activity 2.2, we are saying now P, we're having P here, is a variable point in the electric field of charged sphere A. A is a charged sphere, and R is the distance between point P and the center of the sphere A. See the diagram. So we have the diagram there that is showing us. Now, a learner determines the magnitude of the electric field. You know electric field. Said E equals to KQ over R squared. Don't forget. And we said electric point E equals to F over Q. Electric field. And then we have that one. We have this one, which is F over Q for electric field at a point. So those are the two formulas when we're dealing with the electric field that we'll have in our mind. And they are saying sphere A, here we have sphere A on the graph, is then placed by next to another sphere, which is sphere B. So we have sphere A and B of different charges. So we're saying sphere A and B have different charges. Another set of results are obtained. The graph below are obtained from the results of sphere A and the graph of sphere B. You can see the graph of sphere A and the graph of sphere B. And then we're having now EA, the magnitude of the electric field at a distance of 0.04 meters from the center of charge sphere A. So the graph here is showing you the EA there, which is the magnitude of the electric field at a distance of 0.04. Remember, it's the square of the distance, hence you are having that graph there. So now, it's important for you to be able to see and look here to say, okay, we're having E equals to KQ over R squared. The graph is E. We are having KQ, but on the x-axis, you are having 1 over R squared here, which is your 1 over 0.04. So you can see that this is your Y, this is your M, this is your X. So you can see that, okay, our gradient here is KQ, because our x-axis we have 1 over R squared, and our y-axis we have E. So you're able to see that, okay, this is the graph of Y equals to MX. Our C is 0 there, there's no C. So you can see that this is a straight line. And you can see the relationship that this is a directly proportional. Now, let's go to questions now. They are saying, use the graphs to answer the following questions. State the proportionality between the magnitude of electric field at a point and 1 over r squared. So already from Coulomb's law, you know, but even the graph, it shows you it's a directly proportional relationship. Why directly proportional? You can see that there is a straight line that passes through the origin. Then you know that that is a directly proportional relationship. So that one mark you are given is there for your taking. And then the next question, which I want you to do, is to calculate the electric field for sphere A if the numerical value of the gradient of the graph for sphere A is 680. So I will give you just 3 minutes, but the main thing that I want you to remember is gradient. To say, how do we calculate gradient? Remember, gradient, you know, change in y over change in x. So I'm giving you a clue there, so that at least after 3 minutes, when you come back, we're doing the solution, and I hope you will have done this problem, you will have done it correctly. So see you just in about 3 minutes. Welcome back. I hope you enjoyed your calculation. That includes the calculation of EA using the gradient there. Now you will have what you will have done, you know, for your change in y, you will have said, okay, your gradient is that, and remember your gradient you are given as 680, so you know that your gradient is 680. On the y-axis you have EA, so it's just EA, which is the final EA minus the initial, that was 0, divided by, on your x-axis you had 1 over 0,04 squared. So you are able to just substitute minus 0 as well, so it doesn't make a difference. So you are having that, then definitely you have to cross multiply, and then so that you can get your electric field at a point A. So you're able to do the cross multiplying. You take your calculator, you have done the calculation, you had your 680 and your 1 over 4 squared, and then having done everything, yes, then you are able to get your correct answer. And then you got your final answer, if I can write it here, as your EA, which is the electric field at what? At point A, which we said is 4,25 times 10 to the power of 5. 4,25 times 10 to the power of 25. Then you're able to get your value there, and then that's what you have done. And then you were able to get 4 marks there. So important that you have all your skills of understanding of these graphs. So graphs are important. I know you have done rates of reactions. You were talking about the graph, the gradient becoming steeper. When the gradient becomes steeper, what does it mean? You know, when you increase the concentration, you increase the temperature, you increase those factors affecting the rate of reaction, you were saying the graph becomes steeper. So you know that the gradient is increasing there. When the graph becomes steeper, you are increasing the gradient. You were saying you are increasing the rate of reaction. It's the same kind of thinking that we are having when we are doing this. So we're saying when you learn these topics, don't learn them in isolation because they are all related. Now, here is our next question. It says, how does the magnitude of the charge on sphere B compare to the magnitude of the charge on sphere A? Right, choose from greater than, smaller than, or equals to. What is important when you are responding to this type of questions, learners, is that we started with B. You are comparing B with A. So if you say greater than, you are simply saying that the charge on sphere B is greater than. That's how you must look at it. The charge on sphere B is greater than the charge on sphere A. That's what the meaning of the word greater than mean, which is correct. It will be the charge of sphere B is greater than. Then they're saying give a reason for the answer. Remember, you're getting 1 mark for saying the charge is greater than. So what will be the reason? The reason will be that if you check, the gradient here is becoming steeper. The gradient is becoming steeper. It's moving in that direction. The gradient is coming steeper, which shows that the gradient increases, which will only mean, remember we said this graph is a graph of E equals to KQ, which we said is our gradient, and 1 over r squared, we said is our x. So in the x, we're having this, our gradient is this one. So it means now sphere B, we're having increase. Remember the relationship between E and Q. We said E equals to KQ over r squared. So you know that as we increase the magnitude of the charge, even the electric field will increase. So there is a directly proportional relationship there. So you can see that it shows that the charge here, as we increase the charge, we increase E. So you can see for sphere B, E is increasing. That must be because the magnitude of Q is increasing. Or it can be because the gradient, which is KQ, is increasing. Remember, K remains constant anyway. So you can see that it had steeper gradient. The magnitude of the charge is increasing for sphere B. That makes the electric field as well to increase. So you're enjoying the science there. And this paper, you are going to get the entire 20 marks if you did it correct. I hope you will go and practice as many questions as possible. Now, it will have been a mistake if we don't do other questions. So I'm bringing another question so that we work. Now, look at this one. Two small identical spheres, each with mass m and charge q, are placed in a vertical cylinder. You see now, it's not always horizontal. It is still one dimension. It's just that the cylinder is vertical. The sphere remains stationary when their centers are r meters apart, as shown in the diagram below. Ignore all frictional effects. Which one of the following expression can be used to correctly calculate the distance r? Important. Now, you know our formula is F equals to K Q1 Q2 over R squared. And then if now in terms of looking for the formula now to calculate R, you will have cross multiplied there and you are going to get if Q1 and Q2 are equal, you will get KQ squared, definitely. So you're going to have KQ squared equals to F R squared. Our F is mg, so we can simply just say KQ squared is equals to mg R squared. And we're looking for R, so we can divide both sides by mg. You divide by mg, and then you take the square root both sides to get R. You must take the square root both sides, and then when you get the square root both sides, you're going to get R equals to square root of KQ squared over mg. You see, I didn't go and thumbsuck the answer. I've done the necessary working to get to the correct answer. KQ squared over mg. So you're able to see that your answer is A with 2 marks. So very much important that you do the calculation, and when you choose the answer, you are 100% that I'm going to get my 2 marks. I've done the question correctly. Now, P is a 2 nanocoulomb point charge. So given this one is 2 nanocoulomb. It's a 0.6 centimeter. So it's important. 6 centimeter. Important. Correct SI unit. Don't forget that, because that's where we catch you now to say what is the meaning of nanocoulomb? What is the meaning of macrocoulomb? What is the meaning of picocoulomb? So always have that, because always when you're doing a calculation, you will convert to the relevant, correct SI unit. Our charges are in kilo. So when you say nanocoulomb, you know we must be able to convert to the relevant coulombs that we need. Now the question was, calculate the magnitude of the electric field at X. So you know that the electric field at X can only be contributed by these 2 nanocoulomb that we're having here, which is our point P. And then with no any difficulty, when you are doing it, you will say E equals to KQ over R squared. and then you are using that 2 times 10. Don't forget that means times 10 to the power of minus 9. And then that is nanocoulomb. It was microcoulomb, you will say 10 to the power of minus 6. If it was picocoulomb, you will say 10 times 10 to the power of minus 12. So please always know how to conventions of this SI unit. And then you know your centimeters, your cents, you divide by 100. Centi, you divide by 100, hence you are getting 0.06 there squared. And then you are able to get your 5 times 10 to the power of 3 Newton per coulomb. Remember the SI unit for electric field is in Newton per coulomb, or you can just write it as 5,000 Newton per coulomb, and you are able to collect your 3 marks. I hope that helps you, and you are ready at any time when you ask such a question. Now, point charge S with a charge of minus 2 nanocoulomb, another point, is placed 4 centimeters to the right of charge P, as shown in the diagram below. So we're having these 2 nanocoulomb, we put point X. We check the contribution that was due to X of the electric field. We got 5,000 Newton per coulomb. Now we're given another negative charge there. To say now we are putting where there is X, but for 4 centimeters now, we are putting another charge there. And then we're saying draw the resultant electric field patterns, important electric field patterns, practice them as many. You can see now they are horizontal. So you're able to draw, and you know how we draw them. You have a positive, and we're saying from positive, the arrows will be away. And then we're saying these lines, they must not touch, they must not cross. And then we are saying that it's always towards negative, because we thought of a test charge that it will always be attracted to the negative, and it will always be repelled by the positive. Hence our arrows are like that. So 1 mark for the shape, 1 mark for the arrows for the direction of the electric field, and 1 mark for not touching, 1 mark for that these lines, the electric field patterns, the lines must touch the sphere there. So that is the 3 marks that we got there. So you're able to say, come exam this type of questions, I will do it. At that, as if that is not enough, we had a 2 nanocoulomb, we put the point X, we calculated the electric field experienced by X. We brought the negative 2 nanocoulomb, we have drawn the electric field patterns. Now we bring now the 3rd point charge, which is called T. Experiences a net electrostatic force. So it has a net electrostatic force, and it has a direction as well. So this net electric force is to the left. To the left, that is towards S. That is very much important, because if it's towards S, it means now it's being attracted to there is attraction in terms of the of that one, which will tell us what type of a charge is T. If it's going towards left, if the electrostatic force is towards there, then you know that there is attraction that side. So it must be a different charge from the negative that we're having. State Coulomb's law. By now, I think you are seeing it. You state Coulomb's law, and then for your 2 marks. Now, what is the polarity of charge T? Definitely, you will know that this must be a positive charge. So you're able to say it's a positive charge. Now, 4.3. A 3rd point charge T is placed 2 centimeters to the right of S. 2 centimeters to the right, as we said, as shown in the diagram, experiencing the net. Calculate the magnitude of T. So now we want to know the charge here. What is the charge? So the question is Q. How much is the charge at T? That is what the question is all about. So you are spoiled for choice. The first option, definitely you can use the F net, which is the sum of the force here and the sum of the force there. Then you are able to calculate Q there, which is something that we have done before. And then with no wasting of time, you can simply do like that and do your substitution. So you calculated the F, the force between P and S, and you calculated the force there as T. So the first force is between S and T, which is this one. The second force is between P to T. Remember, we have these 2 charges, and then all of them is experiencing forces due to these 2 forces. So this one, force PT, and the force ST. So those two. Don't forget, for ST, we are having 2 centimeters. You divide by 100, you get 0.02. For PT, you are having 0.04 plus 0.02, which is 0.06. So you are able now to do your substitution. You substitute nicely there. And then don't forget the force that was experienced at the Fnet was that one, which is 2.5 times 10 to the power of minus 4. And then you are able to do the 2, and then you write, and then at the end of the day, you want to find your QT. And then if the math is done well here, which is just now what is left is your calculator, and then you have this minus this. Definitely will subtract them because all of them, they are common. They have QT, all of them. And then when you're done, you divide the 2.5 times 10 to the power minus 4. And if you did that one correct, you get the charge of T as 6.25 times 10 to the power of minus 9. There is another method that you can use. So you are able to get the charge at T. Now we are saying you can as well use the E. You can use the electric field. Not only that, you must rely on the electrostatic force. You can use E net as well to say, okay, if I use E net, I can as well be able now to solve the very same problem. So you do the force due to S and the force due to P. The force due to S and the force due to P. And then you are able to do that. And then with no problem, you know that, okay, I got that one is 45,000 Newton per kilo. And then when you do your inert, which is EP minus ES, then you are able to know that you are having inert like that. And then upon substitution, you get negative 4 times 10 to the power of 4, or you get 40,000 Newton per kilo as your electric field. And then you are able now to bring that to the electric field at a point, and then you are able to calculate the force there. The force. Remember, you have E equals to F over Q in the data sheet, and then our expectation, not much. We just want you to substitute, even if you don't have to. You don't have to make F the subject of the formula. You can just write the formula as it appears, and you substitute in it, and still you will get QT equals to 6.25 times 10 to the power of minus 6. Remember, this will rely on whether you chose right as positive or left as positive. So that's the two ways you can do that particular question. And always, we are always giving you a homework. This one, straightforward and nice, and we want you to enjoy it. It says A and B are two small spheres separated by 0.70 meters. Sphere A carries a charge of 1.5 times 10 to the power of minus 6 coulombs, and sphere B carries a charge of minus 2 times 10 to the power of minus 6 coulombs. The diagram is given there, and then you just have to answer these nice 3 questions. I hope you will enjoy doing this question as your homework, and then you will do it and check it, and you will get total. And then with that, I would like to do my summary that says, today, nice lesson, straightforward, electrostatics. I hope you are more confident now. You are looking for many questions to solve. We said electro means charges, statics means at rest. So we're saying this is the study of electric charges at rest. As I summarize the topic, we said we have charges that are given in coulombs. They are measured in coulombs. And we said we have 2 types of charges, which is the positive charge and the negative charge. And we said the like charges, they repel, the unlike charges, they attract. And we have indicated the elementary charge to say the electron is negative 1.6 times 10 to the power of minus 19 coulombs. A proton, which is positive charge, is positive 1.6 times 10 to the power of minus 19 coulomb. And Coulomb's law, we have stated it using that formula. We have defined both electric field and electric field at a point. So the expectation is that you will continue to revise and do as many questions as possible as you prepare for your exams. And we are saying, I always like to say thank you when I close with this quote from Albert Einstein that says, anyone who has never made a mistake has never tried anything new. So let's continue to practice as many questions as possible, and then let's be ready for our exams. We are saying till we meet again, thank you very much.